Hello everyone, I welcome you all to this class. We are back again to consider this important topic in mathematics, composition of functions. So we want to know how we can find the composition of two or more functions. Actually, we have done this in our previous classes, but we want to still look at more examples on this. So assuming that you have two real valued functions of real variables f and g, and you want to get f composition g of x. This little zero here is the composition symbol. You read this as f composition g. The result of this is f of what? G of x, which means putting the value of the second function g inside the first function what? F. So that's the result. So I'm putting g of x inside the first function f. So let's look at this third example. So if h of x is this greatest integer function, you can see this that looks like a square bracket. So this is the symbol for greatest integer function. So h of x is the greatest integer function, and f of x is the polynomial function, which is 2x minus 3. We want to find h composition f, and the second function the second question is h composition f when x is what? 13/6. So let's go to the first question. So for the first question, we want to get what? H composition what? F. So we want to get H composition F, but we are going to do by we use the definition, right? That's H composition F of what? X. How is it defined? It is defined by, you are going to put the second function, the value of the second function inside the first function. So I'll write my first function here is what? H. I'll do brackets. Then what I'll put inside this H is the value of F. That is F of what? X. I'm putting the second function inside the first function. So this will be what? H of, what is your F of X? F of X is 2x minus what? 3. So that's what I have inside what? H. But by the definition of H of X, whatever you put inside H is what you are going to put inside the greatest integer function. But what's inside H now is what? 2x minus 3. So I'll put inside the greatest integer function. So I'll put this inside the greatest integer function, 2x minus what? 3. With this, I'm done with this. Okay? Then the next thing we are going to consider is what? We are going to do the B part. And the second question is to find H composition F when x is 13/6. So assuming in your exam that what was asked earlier that you should find is that you are asked to find this directly, that is H composition F at when x is 13/6. You need to first of all get this first one we solved. That is H composition F at x. Then when you now get it, you now get this second one. That is, you are now replacing x with this when x is this value. So look at the result we got here. So now we are now evaluating this when x is what? 13/6. So we are going to do greatest integer of, what we have is 2 times x, but what is our x now? Our x now is 13/6. Then what do we have next? Minus 3. All inside the greatest integer function. So this is what will happen. 2 divide itself, you get 1. And then 2 divide 6, you get what? 3. Right? So what we now have, 1 times 13 is what? 13. So we have greatest integer, we have what? 13. We are going to have 13 over what? 13/3 minus 3. All inside the greatest integer function. So this will be our greatest integer of, now 13/3 minus 3. You are going to solve this fraction. You are going to solve this fraction. So I can make the denominator of 3 to be what? 1. So my LCM of 3 and 1 will be what? 3. So you now do 3 divide 3. You get what? 1. Multiply by 13. You have 13. The next you have is minus 3 divided sorry, 1 divide 3 is what? 1 divide 3 is 3. Multiply 3, you get what? 9. All inside greatest. So we have 13 minus 9 over 3, all inside greatest integer function. So 13 minus 9 will give you what? 13 minus 9 will give you what? 4 over what? 3. So you have 4 over 3, all inside what? The greatest integer function. So you are going to have, you convert this thing to decimal. Convert this fraction to decimal. So if you put it in your calculator, this will give you 1.33 something. So 1.33, I can leave it in 2 decimal places. 1.33. All inside the greatest integer function. Now, whenever you have a decimal number, the greatest integer, if you have a decimal number, the greatest integer of that decimal number is the what? The whole number part of the decimal number. So if that decimal number is positive, so 1.33 is a positive number. What is the whole number part of this decimal number? As you can see, it's a decimal number, it has point. What's the whole number part? Whole number part is the one before point. What do you have before point? 1. So the answer to this greatest integer function is what? That whole number part of that decimal, 1. So you remove the decimal part of it if the decimal number is positive. But if the decimal number is negative, assuming you are to find the greatest integer value of let me say negative 2.15. Negative 2.15. What you are going to do is what? You are going to, if it has negative, then what is the whole number part of this? What is the whole number part of this is what? Minus what? Minus 2. So you are going to increase this minus 2 by what? You are going to increase the negativity of it by what? 1. So if you increase the negativity of minus 2 by 1, you are going to get what? Minus 3. So it is similar to this first one we did, but only thing is that if you have a negative, if you want to get the greatest integer of a negative decimal number, you are still going to remove the decimal part. But the answer will not be the whole number part directly. If it has negative, the answer, you are going to increase the whole number part. You are going to increase the negativity of it. You are going to increase the negativity of it by what? By 1. So if I increase the negativity of negative 2, because the whole number part of this is negative 2, increasing this negative 2 in the negative direction by 1, you are going to get what? Negative 3. So that's the result of this. But if it is a whole number, the greatest integer of any whole number is that whole number. So that's all about greatest integer function. So with this, so the answer here is what? 1. And I've done a thorough explanation why the answer is 1. So thank you so much for being part of this class. I'm expecting you in an upcoming class. Bye.